Hello scientific people, how are you today? So today I'm going to perform an experiment to find the density of the irregular shaped object, solid object, that is stone here. So this is the stone whose density I wish to find out, and for this entire experiment I require a Eureka can. So basically this is Eureka can method to find the volume, then we are going to find the density. So this is an Eureka can. As you can see, this is made up of copper, and this Eureka can be maximum filled, be filled till here. As you can see, there is a hole here, so through which the extra water can flow out. So maximum you can fill the water till here. So if I keep the Eureka can till here, the water level can be filled till here, because even an attempt to fill the extra water, the water will overflow from here. As you can see that this Eureka can doesn't have any kind of graduations, right? So other things that we require is a small beaker with graduation. Now I have also a measuring cylinder which has got more number of graduations on it, so I can measure the accurate volume. And to measure the mass I require a electronic balance. What I have done is I have tied this stone with a very thin thread, and now I would be gently lowering it inside the water in the Eureka can. The formula used in this experiment is very easy, people. So we know that density is equal to mass upon volume. So I would be finding the mass of the stone with the help of this electronic beam balance, and the volume shall be measured with the help of the Eureka can. So let's begin the experiment. Okay, so now I'm ready to perform the experiment. So here is the empty Eureka can, and as I said that we are supposed to completely fill it, and any extra water after it gets completely full will come out in this particular beaker. So I'm going to add some water. As you can see that the extra water is overflowing out, and I must ensure that this Eureka can should be completely full. So now almost the extra water has been taken out in this beaker. Now I would be taking another beaker over here with some graduations on it, and I'll be putting it over here like this. Now as you can see, the readings are 20, 40, 60 and 80. Till here it is 100 ml. So let me gently lower this stone. So this is the stone whose density we wish to find out. So first of all I will immerse this stone completely, and the water which will be displaced out will be collected over here, and we know that the volume of the water displaced out will be equal to the volume of the stone. Yes, there is a very little bit error in this experiment because the thread contains very small volume, so it will also displace some extra volume of water equal to the volume of the thread, but that is very negligible. We can actually neglect that part. So now I am immersing this stone, and as you can see, you have to be patient in this experiment. Let the water get completely displaced out. Now I have a problem with this apparatus, because the problem here is the volume is in between 20 and 40. So I don't know whether the volume over here is 25 or 27 or 30. So in order to accurately measure, I have this measuring cylinder which has got good number of readings over here. So let me pour this water over here. Now this reading says that the volume is 31 ml, people. It might be very difficult for you to see, but this is 20, this is 30. Now when I keep it straight, the water level is just above it and the reading shows as 31 ml. So now I know the volume of the stone is equal to the volume displaced, and that is 31 ml. So now let me note it down. So the volume of the stone was 31 ml, and we know that 1 ml is equal to 1 centimeter cube. So this is 31 centimeter cube. That is the volume of the water displaced, same as the volume of the stone. Now I would be measuring the mass of this stone with the help of the electronic beam balance. All set. Now this is the stone whose mass I am supposed to find out, and I have removed the thread from it. So the reading says that the mass of the stone is 63.2 grams. So let me note it down. Now since the mass of the stone was 63.2 grams, so let me put the value over here. 63.2 divided by volume is 31. So let me calculate it. 63.2. So this is 63.2 divided by 31. The answer is 2.038. So that means the density of the stone is 2.038 grams upon centimeter cube. So guys, I conclude my experiment over here. Hopefully you have enjoyed the explanation. Please do subscribe to my channel, and definitely if you have enjoyed the video, please leave a good comment. Thank you for watching the video.